Cool. Say, hey guys, my name is Steve Poitras. I'm a solutions architect here at Nutanix. And today what I'm going to be walking through is the actual demo. So I'll actually be very quick in terms of what we're going to be covering. So I use quote unquote for demo. I'm not a huge fan of demos. Normally they're canned and they're all smoke and mirrors. So it's going to be no fluff, no marketing. It's basically going to be walking through what you do in real life. So
why is marketing in
we'll
quotes?
hold you to that.
Hey, hold me to it.
What isn't marketing? That's
There's a
what.
lot of love for the quote fingers here.
A smart admin.
So yeah, so just kind of set the context. I'm going to be playing like a smart IT admin. Obviously, you know, just go through these very quickly.
Honestly, he's not a smart IT admin. He just plays one on TV.
He's
So,
reversed
are
the
you-
errors back.
so-
to
It's
the
a second
controller.
career.
He's
So
probably
is your
not an
target
admin anymore.
is your target audience your target market now smart IT admins? I mean,
No, we don't want to limit sales to just smart people.
But yeah, so I mean, so really what I'm focused on here is operating my IT services. At the end of the day, what I really care about is all those services running on my infrastructure. And so we're going to be actually working with two NX 3450s, which is one of our latest platforms. So what we're going to be walking through is go through a full deployment of a Nutanix cluster. So essentially what you do once you got this from the factory, we'll go ahead and configure and expose storage resources. We'll then take you through the Nutanix user interface and what it's like to monitor and manage this. In this environment, we're actually running Splunk. So the deck earlier for the linear scale showed VDI as an example. However, with Splunk, which we just produced that RA, you can actually notice linear scale as you scale out the number of nodes and your Splunk instances as well. The main thing is really just that those storage controllers scale as your number of nodes grow, so you don't get that bottleneck there on that side. Then we'll take a look at the alerts and analysis framework. So we can actually do some event management and do some impact analysis. And then one of the things that I think is the most efficient is the actual scaling. So how you actually scale a Nutanix node. And we'll scale from 4 nodes to 8 nodes. So as Benny mentioned, one of the biggest things that we use in terms of deployment is Avahi, which is the Linux implementation of Bonjour. This allows us to essentially discover new nodes on the network prior to them having like an actual IP configuration. In this case, these actually are sitting in a data center out in San Jose, so they have IP addresses. So this is the screen that we would get once we navigated to that IPv6 address. So here, we can just go ahead and name this cluster. So here we'll call this TFD CLU02. Here we can set all our IP configuration options, subnet masks, default gateways, etc. And these are the nodes that are actually discovered on the network. So in this case, this is just a single 3450, which is 4 nodes. As you can tell, we've already configured the IP addresses. So we'll just select the nodes and click Create. So what this is doing here is when the new cluster is configured, there's a lot of back-end tasks that need to take place. All the metadata, all the distributed file system infrastructure, for example. That all needs to be configured in the cluster itself. The Cassandra ring needs to come up, etc. So if you take a look at this, we can see that the cluster has been successfully initialized. And now if we actually just refresh this page, we'll see how good latency is going over this Wi-Fi and Twitter. So here we can see the cluster has been configured with all the nodes. We can see all the essential infrastructure services are up. And then if we were going to go ahead and start this cluster, all we would do is just click this Start button here. And then the cluster would be up running and would be ready to actually start provisioning and configuring storage. In this example, we're actually not going to start this cluster just because I'm going to use this for the scale out. So we need to actually go ahead and destroy this cluster. So, and from a, a big thing there, from a configuration standpoint, realistically, normally deployments can take, days, weeks, sometimes longer than that. So here, in a matter of minutes, when I configure a new block, it probably takes me 3 minutes, 2 to 3 minutes once it's rack stacked, cabled, powered on. And the longest part is actually just ESXi booting. Other than that, it's fairly straightforward and efficient. Okay. So the next thing, we'll actually go through the Nutanix UI. And for some reason, the projector actually cuts part of the screen off. So Let me actually just size it appropriately. Apologies for any latency here. We'll probably see Bursa's Twitter.
Would it be possible to get a dark background on that? Yeah, a little washed out.
Right now, it is. This is the only theme. However, that's definitely a good feedback. So for me, TweetDeck, I use the dark theme just because it's easier on the eyes. So that's definitely a good piece of feedback, and we can take a look at that.
The adapter that, not to criticize Chris Wall.
Never criticize Chris Wall.
He's even got a proper laptop too. It's not a fruit, so
Yeah.
it's got to be the projector.
Yeah. So this is the Nutanix user interface. So here is basically our main UI dashboard. I can see my basically compute summary. So what hypervisor I'm running. Here I'm running ESXi, which coming back to the point earlier about upgrades, I'm actually running 5.1. So I've upgraded this using VUM. I can see a high-level storage summary. So how much storage I'm actually using, total amount of VMs, my amount of hosts. So here I have one 3400 or 3450. I can also see storage metrics, so current IOPS, bandwidth, latency, CPU and memory usage, as well as any alerts and events. So here is basically an audit trail of exactly what's been going on in my environment. So now, for example, say previously we configured our Nutanix environment and we want to create a data store and expose that to ESXi. What we do is just create what we call containers. So here we'll just call this TFD rocks. Here we can specify our storage pool, our max capacity. We actually want to mount this on all of our hosts. And then we also have the ability to configure our replication factor or any reserve capacity, and also enable compression. So in this example, we'll actually enable inline compression, which means as blocks are actually being written, they'll be compressed before they're actually written to disk. So here we'll go ahead and click Save. Okay, so here we can see that it's been created and it's mounted the data store on all of our hosts. Now, if we go back to vSphere, here we can see our 4 ESXi hosts. Now we'll just click on one of them. Or actually, we'll just go to related objects. And here we can see that the data store has not only been created on the Nutanix side, but it's also been exposed to vSphere. So now all my hosts in this cluster can actually start to provision storage, provision virtual machines, and start leveraging that new data store. The other thing to note is we're running Splunk currently on this environment. So this is an environment that I've been using for Splunk benchmarking using the Splunkit test harness. So here we can just see an example of one of the Splunk instances which is running. So the next thing here is, the Nutanix user interface is meant to be kind of a single point of truth. So normally, on a day-to-day basis, I spend all my time in vSphere or Power GUI. However, you can get a lot of that monitoring information from the Nutanix UI, so I can see all the associated virtual machine metrics, what's taking the most amount of IOPS, CPU utilization, etc. And then another interesting part is on the storage side. So, here, for example, I can see my utilization, my tier usage, how many containers and how many virtual machines, as well as how many hosts those containers are mounted on. And then, in this case, we're actually running Splunk, which is very good, especially with syslog data. You can get very good compression with that. So here we're actually seeing around a 30% compression ratio. So of 700 gigs, 500 of those gigs are actually being saved just due to compression space savings. From here, I can also dive down and see my storage pool. I can see the 3 containers that I are currently using. And on all those, I can get IOPS, IO bandwidth, latency, etc. I can also see exactly what sort of IO footprints, whether it's sequential or random IO, that's taking place. The other note with compression is if I enable inline compression, but the IO is actually random, I'm not going to compress that just because we have that insight into the IO footprint. You'd get very, very bad performance if you were trying to compress random IO. I'll go into hardware here. So here we can see we have 4 hosts, and then I have 4 discovered hosts. So previously I configured a full Nutanix block However, I destroyed that because that's what I'm going to be using to scale out the cluster. I can also see a diagram here. So here, for example, I can see my 4 nodes, all the associated disks. In the case of, say, a bad disk or a node failure or anything like that, I'd see these alerts here, actually be able to see exactly which disk had failed or any associated alerts. So we do proactive scrubbing. So if there's any I/O errors for a particular disk for a subset of time, we'd get that alert, and we can actually kick off support requests there. So here I can see this host has a few alerts. I can click on the alerts and actually see all the alerts that are generated, as well as their status. By itself, alerts really don't give me too much information. It's good to see that a disk failed or something associated has gone wrong, but realistically what I care about is what impacts did that have. So here, for example, we can see we have some alerts here. Personally, my eyesight is not all that good to see what's up there. But here we can actually see that the CPU utilization is abnormal or out of bounds of what we normally expect. So if we wanted to dive deeper, we could actually create a new metric chart to take a look at CPU utilization. In this case, we'll actually use this for the cluster in general. And then we can actually see we've seen a CPU spike here. If we didn't expect the CPU spike, this is something where we could actually go out to the support portal. Here we could actually file a ticket. And then if we wanted to actually get someone to take a look at our system, we could actually enable remote support. So this will actually enable the support folks to log into the environment, take a look, pull logs, etc.
Cool.
And you can do this on a temporary basis.
You specify the credentials they'll use to log in, right?
Was
or
it?
do they have a guard mode?
So basically, there's a secure connection. When you do this, when you enable a remote support, it'll actually enable a secure connection back to the support engineer. So it's essentially similar to like a reverse proxy, so to say.
Yeah, what we established is a reverse tunnel. So through SSH.
Mm-hmm.
Thank you.
Cool. Cool.
So hang on. How? From what is the endpoint that the engineer can jump into? Because I know that my security guys will not be allowing that sort of access outbound. Like SSH outbound is banned. So how do I enable this service?
So as part of the cluster setup and the setup guide education, what we ask the customer to do is open up a couple of ports, and they can select even port 80 or port 8443 and open it for outgoing connections to Nutanix support.nutanix.com. Once they've opened that up and then they press the yes button here, we're going to use whatever port they opened, port 80 or port 8443, and create an SSH tunnel over that port. And that ends in Nutanix support site.
Okay, so you have to pre-configure a permanent outbound port access from the infrastructure in the production line, in
Correct.
the production network. Okay.
I mean, yeah, if you want it to happen seamlessly when you press the button.
Okay.
Cool. And then so another thing that I'm going to go ahead and take a look at here is, Vinny talked about our REST API Explorer. So, one of the biggest things, and, there's obviously been some discussion about this, is interfaces into the Nutanix platform. So GUI is good, but for example, me with vSphere, I use PowerCLI and Power GUI for 90% of the things that I do. So one of the big things that's coming is a REST API. This is just a small example for a small subset, in this case setting the HTTP proxy, but really just wanted to demonstrate what you could do with this. So here we can actually see all the associated REST operations for this HTTP proxies, as well as expand and get detailed information about them. So not only can I actually execute these REST API calls, I can actually take a look at what the schemas look like. So when I'm actually formatting a REST call, I actually know exactly what JSON or what format to structure my call with. Here I can also try this out, where I can see what the request URL would look like with the IP. This is the exact same request URL that I'd use interfacing this with an orchestration tool, etc., as well as any response bodies, response codes, or headers. So here I can essentially see, number one, what's all exposed from a REST standpoint, and this example is just one example out of there's 250 plus REST calls that are available, as well as the schema and how I would actually leverage that. So now the next thing here is we have at current 4 nodes, and one of the biggest benefits is the ability to actually scale out the infrastructure. So here, for example, we'll actually scale from 4 nodes to 8 nodes. And we actually went through this last year. We were doing this all through the CLI. Now it's built into the Nutanix UI, and we can automatically discover the nodes as well as add them to our cluster dynamically. So here I'll just specify the IPs for my other environment.
So one thing to note here is that we are using zeroconf. That does not depend on any IP addresses pre-configured or factory configured. It goes over the configuration of IP addresses goes over IPv6, and we are able to configure IP addresses of the controller VM for the ESX hypervisors, the host itself, and the IPMI IP as well on the BMC. All 3 on this screen. So it's easing the admin's job of initially configuring the system.
Yep. Cool. So now what we'll do is we have all our IP addresses configured. We've selected all the nodes, and we'll go ahead and click Save here. So now what this is doing is this is actually adding all these hosts into the Nutanix cluster. So one of the biggest things is spreading of metadata. That was a question that Howard had last year, whether or not metadata was rack aware, whether or not data was rack aware. So this will actually insert these nodes into that ring in a rack aware manner. So basically, the ring will go, rack 1 or block 1, block 2, etc., and vice versa. Just so if you were to lose, say for example, you had a full power outage, you lost a full 4 nodes, you wouldn't be hurt by that.
Right, and
Yeah, blowing circuit breakers happens all the time.
Yeah. As much as we want to account for redundancy from a power standpoint, there's always going to be issues there.
You don't have idiots in your data center blowing circuit breakers?
No.
And the other
Lucky
thing,
you.
to
Yeah,
note,
maybe I'm different.
He runs his own data center in his basement, so he's the idiot.
No.
Actually, that big problem is working in New York City office buildings and having the IBEW Local 3 electrician try and figure out which circuit breaker is for the cubicle he's trying to rewire by turning them off and on.
Oh.
Have a big blow-up rack in front of your house.
Or a red.
Yeah, what was your address again?
Careful what you're saying there, buddy.
Anyhow.
Everywhere else is power distribution.
So-
Startup idea.
as these new nodes are added, I mean, they don't have any data or metadata. So once they're added, again, MapReduce runs on these nodes and the remaining cluster and balances the data across the cluster over time.
Cool. Yeah, so here we can see all the hosts being added has been successful. So we'll just go ahead and refresh the UI here. All right, cool. So here we can see that our hardware is actually 8 hosts. We have 8 hosts that are powered on. At this point, we've essentially doubled our compute capacity. We've doubled our storage capacity as well as our memory capacity. So now if we were just to go back to our dashboard, we can see that 15 terabytes of storage that we could actually leverage has now turned into 30 terabytes of available storage capacity.
When you say free physical, is that usable or is that just the raw?
It's the raw.
Yeah,
That's
so
the raw.
yeah, this is the
you guys
raw.
can define number of copies and things like that, right?
Yeah. So essentially, yeah, we provide some variations on number of copies,
Okay.
and therefore we don't want to say how much is usable. That depends on your policies.
Yeah. It's like asking how many VMs can I put in here, you know, like, well, how big are they?
Yep, absolutely. So next thing we're going to do is we'll actually take one of our containers here. So here we'll just say this TM we have 2, and actually here we'll create a new container here. So let's just say 50.
Are there any guidelines as far as sizing containers, like how big or how small to make them? Like, is there a limit to how big?
No.
I've been liking larger containers, especially with VAI and stuff like that.
Yeah. So yeah, it's actually a question that a lot of people have because so normally when I was working with like NetApp FAS or anything like that, I want to keep my VM to data store ratio, maybe 60 to 100, something along those lines. With the Nutanix appliance, Essentially, the larger the container, the better. So how I normally would use containers is just by the policies that I want to apply to the data and the IOs, which normally is one for virtual machine, which is just RF2, so all my VMs that I want to be heavily protected are in that container, and then one for data where I want compression on. Okay. And then from there, I just leave those containers, the less number of containers, the better, just because you can get that advantage from a VI standpoint. And then also, you don't need to worry about the whole VM to data store ratios that you normally would in the past. Yeah. So when I had a 48 node cluster where I was running 3,000 plus virtual machines on a single 200 terabyte data store. Normally that would be unheard of, but just because of all the IOs occurring locally, I actually have the ability to do that. Yeah. Plus, it makes things easier from a management standpoint.
Yeah, you're not also, all data stores tend to lose a little bit at the ends and stuff like that. You can't fill them up completely and stuff. So that's cool.
Absolutely, absolutely. So here, we'll just go ahead and create another container. Okay, so let's went ahead and created the container. So previously we just went ahead and added our nodes. So let me just refresh the vSphere UI here.
And that's why the vSphere web client sucks.
Exactly. Now, my fingers are crossed, it's getting better. So here we can see, previously we had...
We should hope it's getting better because they're taking the other one away.
I just keep jabbing it in them, hoping they'll fix it.
Asking for things doesn't seem to work.
But yeah, so here, previously we had 4 hosts. As you can see, we've actually scaled out our environment. So now we have an 8-host cluster. If we click on...
It did that automatically?
So I actually use PowerCLI to just add it. So right now it doesn't automatically add the ESXi host into a vSphere cluster.
That's fine. I was going to ask about licensing and things like that. And you've got that covered.
Yeah. So yeah, personally I just use PowerCLI to add them in, but thought I made it. So here I can go ahead and see my data stores, and here we can see that new TFD demo that we've just created, and that's actually going to be on all the hosts. So at this point, I can have DRS actually come in, spread the VMs that were previously running on my first 4 hosts to my now 8 hosts. So that'll take down utilization from a host level, and then also spread that I/O amongst all the nodes participating in the cluster. So that's what I had from a Nutanix UI standpoint. Any questions or?
Yeah, you mentioned the upgrades. It was a bundle or something. Could you just briefly walk through that process, how painful it is, et cetera? Yes. I don't expect you to actually run a code upgrade, but what do you have to do?
From a Nutanix perspective,
yes.
Or from? Oh yeah. So actually, what I can do.
And I realize it's a little washed out on the PowerPoint, or on the slide, but.
Yeah, no worries, no worries. So realistically, what I do, so this will probably be a little bit difficult to see. But whenever I need to upgrade a cluster, I actually just run essentially 2 commands. And then from there, it'll automatically deploy the packages to all my Nutanix controllers. And this is all done real time while the cluster is running. So for example, if I wanted to, I'm already running a pre-release version of our code. However, if I wanted to upgrade that, currently while we were operating our Splunk workload, we could actually execute this command. It'll do them in an incremental rolling manner where all my Splunk IOs will continue to process. As these Nutanix controllers are upgraded, those IOs will be forwarded to another Nutanix controller as it's being upgraded. So the auto pathing that Benny talked about earlier, where essentially we modify the route to that mount point for that NFS data store. That'll go not to the local controller while it's being upgraded, but rather to another remote controller. And then once it comes back online, that route's modified where it's all occurring locally again.
So is that a PS that they have to do for an upgrade because you're running custom code here, or is it something that the end user can do?
So essentially, this is what Steve runs. Let's talk about what this is. So this, you have to log into any controller VM and issue these commands. Okay. There's nothing external on ESX. I mean, this is hypervisor agnostic. Upgrading our software has nothing to do with the hypervisor.
I understand that.
Okay.
I'm saying, like, do you just send them that script, or what's the, hey, I'm the smart admin.
That's
what do I do?
That's what Steve does because he likes the CLI. What we're gonna work on very soon is it'll all be available on the UI.
Okay.
And it'll show new.
Well, that's what Steve does then, and that's what the rest of us do then right now, too, right?
Yeah.
So
So then on the UI, you'd just download the package, and the download would happen on the cluster on any one CVM, controller VM, and our software is responsible to spread it around in a peer-to-peer fashion, making sure the load is not big on the network and all that, and rolling upgrade this.
Is there any maintenance mode of the host involved, or it's all
no
non-interruptive and completely invisible to the vSphere side?
Correct.
Okay.
And you can monitor the progress.
I'm assuming the answer is yes, but can you say, I'll do one node now or two nodes now, and then do the rest of the cluster next weekend? Because I just know that there'd be some clients who would go, I'm nervous about what would happen if it suddenly didn't work properly and we'll break the whole cluster.
We could do that, but we don't support that. We encourage that you upgrade the whole cluster rather than having part of the cluster running old software, part of the cluster running new software.
Yeah.
I mean, we'll work that way, but I mean, it's best that you upgrade the whole thing.
it sounds like if you've got a client that wants that, you're going to end up having a whole separate cluster to do.
To be fair, that's how like UCS works. You don't just upgrade a part of it, so that's normal.
Yeah. Yeah, but I mean, the truth is, there's always some period of time when you've upgraded part of it. You're just encouraged to keep it short.
Yeah.
Shouldn't be a permanent action or a long action.
But even VMware's like that, you know,
So-
like you shouldn't have a, down level hosts in your cluster for too long, that sort of thing, you know.
Yeah, I'm not suggesting that it would be a permanent thing. I'm just suggesting there would be some
I
clients who say,
understand because we tend to be that way as well, you know, like we tend to be pretty skeptical of upgrades and things like that because they go wrong half the time. So.
yeah.
That's generous.
Ryan, were you going to say something?
Yeah. You guys said you're working on hypervisor to hypervisor reinstall migration. Will you be able to run a single cluster since the CVM is agnostic with multiple hypervisors?
Yeah, I mean we have.
So one NFS share shared out to both KVM and.
Yeah, I mean so internally we have prototyped that, and in fact even had a virtual machine powered down on ESX, and we ran a script, converted that to a KVM friendly format and powered it up on KVM on the same data store without any data migration. But again, that's just a prototype.
And that's one thing that I'm really looking forward to as well, because in a lot of environments, a lot of people are using vSphere for production. However, Hyper-V or for dev test, just because of licensing costs. So in that case, you can actually have the goodness where all the storage resources are available to all hypervisors. So if my dev test environment is very light from a storage footprint, my production environment can actually take advantage of those additional storage resources.
Yeah, so. Well, my dev environment is likely to be light from an IOPS point of view.
Yep. Oh, yeah. Cool. Okay. So, just to kind of give a quick recap what we did, I'll brush through these because PowerPoint is not always the funnest thing, but realistically what we did is we deployed a brand new from the factory Nutanix cluster. We configured storage resources and exposed those to the ESXi hosts. We took a look at cluster performance and utilization, as well as did some alert impact analysis using the alerting framework, analysis framework. And then also took a look at the REST API. The REST API, I think, is one thing that'll be very important, especially with people really leveraging a lot of automation or orchestration environments. Essentially, what I can do is, as part of my overall workflow, hook into the Nutanix REST API and do what I need to do. Realistically, though, at the end of the day, once I configure a storage pool and a container, that's really the extent of what I do from a storage config standpoint. And here we can see when I scaled up from 4 to 8 nodes, all that additional storage capacity is just transparently available to all those data stores. Then from an analysis standpoint, we went ahead and configured a custom metric to take a look at CPU utilization, as well as did some historical trend analysis. And then finally, we actually scaled up from 4 Nutanix nodes to 8 Nutanix nodes. And, you know, conversation aside, this realistically took probably 30 seconds, obviously definitely less than a minute. So it's a very efficient process when we start talking about scaling out. Rather than being a 2-week effort or et cetera, this is something that can be done very easily. Here we did it through the UI, but then also very efficiently as well. And you know, the big outcome there is we transparently doubled compute and storage capacity while workloads were running it in the background. So,
I'm assuming all of this works with like Update Manager and stuff like that for VMware?
Yeah, so I use VUM to upgrade environments because manually, you know, mounting ISOs or anything like that. For larger
just letting
environments
it do it, and it's a decent tool for that.
Yep.
How does a controller VM interact with ESX then? Is it just listed as an appliance VM that comes up and down with ESX, or is it something I have to go shut down myself, or how does that work?
Yeah, so I'll say kind of current state and to-be state. 2B, it will be like a full appliance virtual machine, which, you know, if the host is entering maintenance mode, it'll automatically power itself down, or when the host comes up, it'll automatically power it up. With power on, for the host standpoint, the CVM will automatically boot. That's with just the startup rules. However, right now it doesn't automatically go down. So it is a little bit of manual intervention just to power down the CVM. For me, I actually just script it in PowerCLI. However, it is something that, you know, right now is a little manual process, but in the future it will be a full agent VM where it'll automatically shut down and turn on with the host as it comes up and comes down.
Cool.
So.
We do have to wrap this up now.
Oh no!
Steve, I think we could have talked to you all day. Absolutely.
Those aren't nearly big enough to be.
So is there any final questions or
Nutanix
comments that anybody
nodes.
wants to make?
I have a strong request for per VM snapshots.
We do have that. Yeah, so snapshots.
Sounds like it's your lucky day.
Yeah, so snapshots actually all occur on a what we call like a vDisk level. So a virtual machine would actually consist of multiple vDisks.
Right.
And then so when we actually do a snapshot, it's occurring at the vDisk level itself.
Right. So what we had and what we didn't cover is our disaster recovery. There we have a notion of a protection domain, which is a collection of VMs. And within a protection domain, we'll snapshot all the VMs that are part of the protection domain. But inside that, the question is which ones you want to consistently snapshot. So you can create consistency groups, and we'll quiz all of them together and take a consistent snapshot from them. So you can have a collection of consistency groups all together as a protection domain for which you apply schedules. And you can have multiple protection domains and multiple schedules.
And those are redirect on write snapshots?
Yeah, essentially. And you can have...
We need to talk in excruciating detail. And,
Okay.
and you guys need to emphasize that more. Because I think you'll get universal concurrence in the room that VMware's log-based snapshots doth sucketh.
Yeah.
Not
Log-based?
And you guys can replicate too,
Disagree
right?
with that.
Yeah.
Yeah, we
that they're
replicate.
logged.
Maybe I missed
Or
part
that
of
they
what
suck
was you guys talking about that or
Like a
whatever, but that's
transaction log.
cluster to cluster replication,
Yep.
that
Yep.
sort of thing. How is that set up, and do you define a volume on the other side?
They can talk to Satya.
Yeah. So actually, like
also
as Benny was saying, you basically just create a protection domain, which is the group of VMs, and then your consistency groups will be the VMs that are snapped in a crash consistent manner.
Yeah.
And then from there, you say for this snapshot schedule, I want to replicate it to these n number of sites. So it's not just a pure site to site. You can have a one-to-many relationship, or bidirectional as well. And then from there, it'll automatically create the target protection domain. It'll do the mapping between the containers where the VMs are actually existing. And then when I want to, when I replicate obviously full initially, but then anything other than that is all incremental. And this is all on a sub-block basis, so it's very efficient from a replication standpoint.
And also compressed.
Yeah.
Compressed. I'm assuming asynchronous.
Yeah.
Is it
Asynchronous, yeah.
configurable intervals, or it just does it as fast as it can? Or?
No, it's configurable.
Okay.
And you can set up different schedules and multiple schedules as well.
Cool.
I have two really quick questions.
They better be quick, Robert.
Yep. First, is the API Explorer there now, or is it coming soon?
So
In
what I
mix.
showed today was actually an upcoming release. So
Okay.
it's not something that's currently there today, but it's something that will be exposed in the next.
It'll be on the next release.
Okay, cool. And what happened to Infinity?
Infinity, what we've done is, maybe Greg can take that question.
Infinity became finite.
Well done.
He stood up and volunteered.
It's fine. So Infinity, for those of you who weren't here last time, was our internal project to scale out a very large Nutanix cluster, right? To demonstrate to ourselves and to everybody the scalability. So that project lives, but what we did is something we think is beneficial. We actually are doing it in a real customer environment. So we actually have a very large customer who's building out a 1,000+ node cluster. This is an actual customer. We have the order. We're shipping boxes. So we've actually expanded Infinity in a commercial realm, and then that is being built right now. And when that is done, and when we get performance feedback, we'll share it with everybody that we can. So Infinity went from an internal project to a commercial, real-world deployment.